Hello and welcome to my AQA Level 2 Further Maths Prediction Paper 2 for this summer. Before we begin, some general information. Firstly, I highly recommend that you download and try doing this paper before watching the video. You can find a link to that paper in the description. Secondly, this paper perfectly covers the advanced topic list released by the exam board back in February. There is, however, no guarantee that questions will be asked exactly in this way, but this paper is surely excellent practice for your summer exams. Finally, due to the nature of the questions you're being assessed on in this paper, some of the questions may have alternative approaches. I'm going to show you one approach in this video, but as long as you get to the right answer, other approaches may be valid. For this question, I'm going to substitute x equals 0 into the equation. So we'd have y equals 3 times 2 to the power 0, and 2 to the power 0 is 1. So y equals 3 times 1, which is just 3. This means the y-intercept is positive, so we can rule out graphs C and D. Now if we go back to the equation, we can see we have 2 to the power negative x. This means if x is a really large number, then y will become a really small number, so it must be graph B. For this question, we'll look at the general equation of a circle. This circle would have centre AB and have radius r. So if we look at the centre we have here, 3, negative 4, the numbers that go in the brackets would be the opposite signs of these, so negative 3 and positive 4. This means we can rule out the top two answers. If we now look at the radius, which is 15, the equation has r squared at the end, so we need to square 15, which gets you 225. So the answer is this one. For the first part, we need to decide if x times y is less than 0. Let's pick some numbers for x and y and see what happens. So in the first one, if we pick x as negative 6 and y as 2, then negative 6 times 2 is negative 12. This is less than 0, so it certainly can be true, but can it also be false? Well, if you look at the second inequality here, we can have any number from 0 to 3, and that includes 0. So what if instead it was negative 6 times 0? Well, that would give you 0. That's not less than 0, that's equal to 0. So this can be true and it can be false, so it's sometimes true. Now we need to see if x squared could be greater than y squared. We can write inequalities out for x squared and y squared. So for x squared, if we look at the numbers negative 8 and negative 5 and square those, we get 25 and 64. So x squared must be in between 25 and 64. If you do similar for y squared, 0 squared is 0 and 3 squared is 9. So if x squared is always in between 25 and 64, and y squared is always between 0 and 9, then x squared must always be greater than y squared, in which case this is always true. If we look at the first multiplication for this matrix, then when we times negative 3 and 0 by 4 and b, we should get 2a. So negative 3 times 4 is negative 12. We add to that 0 times b, but that's just 0, and that must equal 2a. So we've got negative 12 equals 2a, and if you divide both sides by 2, you'll get a equals negative 6. For this question, we'll look at the second multiplication, which will be 2b and b, multiplied by 4 and b, which must give you 20. So 2b times 4 gives you 8b, and b times b gives you b squared, and that must equal 20. If we now rearrange so all of the terms are on the left we have b squared and 8b, and then we take 20 from both sides, so we'd have take 20 equals 0. This is a quadratic, we can factorise this one, it would be b plus 10 and b minus 2 equals 0, which gives you two solutions for b, which are negative 10 and 2. If we start by evaluating the left-hand side, we have 2 to the power 6, and then we multiply the powers so it's times m to the power 30. And this is identically equal to, do a similar strategy on the right hand side, a to the power 3, and then we multiply the indices, so m to the power 3b. 2 to the power 6 is equal to 64, so we have 64m to the 30 equals a cubed m to the power 3b. If we now compare both sides of this identity, you can see that 64 must be equal to a cubed. So 64 equals a cubed, then cube root both sides and you'll get a equals the cube root of 64, which is 4. If we also compare the m's, we have m to the power 30 and m to the power 3b. So 30 must be equal to 3b. If we divide both sides of this by 3, you just get b equals 10. To start this question, we'll square both sides. If you square the left hand side, the square root disappears, and if you square the right hand side, we've got n to the power negative 40 all squared. We can now do some simplifying. On the left we have n to the 49 times n to the 28. When you multiply you add the powers, so this gives you n to the 77. We can simplify the right hand side a little bit as well. Since we have a bracket to the power, you can just multiply the powers. So negative 40 times 2 gives negative 80. When you divide here, you'll subtract the powers, so this can be n to the 77 take away t, and it should be clear from this that 77 take away t must equal negative 80. We can solve this equation by adding t to both sides. On the left that gives you 77, and on the right negative 7t. Then divide both sides by negative 7, and you'll get t equals negative 11. To start this question, we'll expand the brackets. We have y equals x plus 1, and then times by x plus 2 squared, so that's x plus 2 and another x plus 2. Let's start by expanding the first two of these brackets. So x times x gives you x squared, x times 2 gives you plus 2x, 1 times x is 1x, and 1 times 2 is plus 2. We can simplify this. 2x add x is 3x, so we end up with x squared plus 3x plus 2. We then need to times this by the final bracket, which is another x plus 2. So x squared times x is x cubed, x squared times plus 2 is plus 2x squared, 3x times x plus 3x squared, 3x times 2 plus 6x, and then 2 times x plus 2x, and 2 times 2 plus 4. We can now simplify this. If we simplify the x squareds, we've got 5x squared. If we simplify the x's, we've got 8x. So we end up with x cubed plus 5x squared plus 8x plus 4. We now need to differentiate this. So we'll do dy by dx. If we start with x cubed, if we differentiate that, we get 3x squared. Then if we differentiate plus 5x squared, we get plus 10x. If we differentiate plus 8x, we get plus 8. And of course the plus 4 will give you 0. So this is the answer. In this question, we're told the 50th term is 327 and also the 65th term is 432. This means the difference between these terms is 105, but the difference is also equal to 15 terms. This means that 15 lots of the difference must equal 105. So 15 times the difference is 105. If you divide both sides by 15, the difference is 7. Since this is a linear sequence, it must have nth term 7n plus something, which we'll call c. We know the 50th term is equal to 327, so 7 lots of 50 plus something must equal 327. If you rearrange this, 7 times 50 is 350, so c is 327 take 350, which gives you negative 23. So we know the nth term is 7n take 23. In the question, we're asked to find the first term which is greater than 1000. So we can write the nth term, 7n take 23, is greater than 1000. If you add 23 to both sides, you get 7n is greater than 1023, and then divide both sides by 7, you'll get n is greater than 146.14, and so on. Now we want the first term that is greater than 1000, so it isn't the 146th term, we must go to the next term, 147th, since the value of n must be an integer. So we end up with 147. In this question we're told that m is the midpoint of the line AB, and we're given the coordinates of A and the coordinates of B. So we can work out the midpoint by adding up corresponding coordinates and halving them. So if we add the x coordinates, we get 0 add 10, and then half that gives you 5. If you add the y coordinates, we have 6 add 2, and then half that gives you 4. This tells us the coordinates of m are 5, 4. We're also told in the question that cm to md is the ratio 2 to 1. So if we look at how to get from d to m, if you look at the y coordinates, we've gone from 5 to 4 here, so this vertical line must have a distance of 1. If you look at the x coordinates, we've got 8 and 5, so this horizontal distance here must be 3. This is for the line MD, and we know that cm to MD is in the ratio 2 to 1, so to get from M to C, we just need to do this twice. So rather than going down 1, we go down 2, and rather than going across 3, we go across 6. Now start at point M, which has coordinates 5, 4, and go down 2, Then the y coordinate goes down 2, so it's 5, 2. Then go left 6, so the x coordinate will go down 6, and you end up at negative 1, 2. So the coordinates of C are negative 1, 2. In this question, I notice both of the terms have the bracket x minus 2. One of them's to the power 4 and one of them's to the power 5. This means we can factorise out x minus 2 to the 4. I then draw a big bracket like this. To get from x minus 2 to the power 4 to 9 lots of x minus 2 to the 4, you just multiply by 9. And to get from x minus 2 to the 4 to 6 lots of x minus 2 to the 5, I need to multiply by 6, but also I need another one of those brackets, x minus 2. We can leave the first part alone, but then simplify what's inside the large bracket. We have 9, and then if we expand the bracket, we get plus 6x minus 12, which of course simplifies to 6x minus 3. This itself can factorise. It has a factor of 3, so this would be 3 lots of 2x minus 1. We're now ready to write the answer, which is all of these times together, but it's common to write the number at the front. So we'd have 3 lots of x minus 2 to the 4 times 2x minus 1. In order to simplify this, we'll factorise the top and the bottom. We're going to start with the bottom. You should notice, because there's 2 square numbers here, this is going to be a difference of 2 squares. So it would factorise as 4y plus 3 and 4y minus 3. If we factorise the top, we can take out a factor of 2 and also a factor of y to the 5. If we then consider what would go in the brackets, to get from 2y to the 5 to 8y to the 6, we'll need to multiply by 4 and also another y. So it's 4y, and to get from 2y to the 5 to 6y to the 5, we just need to multiply by 3. You've now got common factors you can cancel, so we can cancel out the 4y plus 3 brackets. This leaves you with the answer, 2y to the 5 over 4y minus 3. In this question, we need to complete the square. If you look at the first 2 terms of this quadratic, they have a factor of 3. So we're going to factorise 3 out of those, which would give you x squared plus 8x. And then there's still this negative 1 at the end. We're now going to focus on what's inside the bracket, so we'll write everything else out as it was, and inside the bracket we're going to complete the square. So the coefficient of x was 8, so you halve this to get 4, so we need to do x plus 4 all squared. When you square 4 you get 16, so we'll take that away, and we can now expand this large bracket. We'll do 3 times x plus 4 all squared, which gets you 3 lots of x plus 4 all squared, and then 3 times negative 16, which is negative 48. And don't forget this negative 1 at the end. You can now simplify the last 2 terms. Negative 48 subtract 1 is just negative 49, and now compare it to the form in the question. You can see then that a is 3, b is 4, and c is negative 49. In this question, we're told A has coordinates 3, 2, so we'll mark that on the diagram. We're also told that line L1 is parallel to the x-axis. This means it's a horizontal line, and since it goes through the point 3, 2, it must have equation y equals 2. Since lines L1 and L2 meet at a right angle, we know that line L2 is a vertical line, and it goes through 3, 2, so it must have equation x equals 3. We're also told in the question the equation of this diagonal line is y equals negative 2x plus 16. In order to solve this question, you need to find the coordinates here, which I've marked B, and here, which I've marked C. The coordinates of B are where the line y equals negative 2x plus 16 intersects the line x equals 3. So if we substitute x for 3 in the first one, we get y equals negative 2 lots of 3, add 16, negative 2 times 3 is negative 6, so negative 6 add 16 gives us a y value of 10. This tells us the coordinates of B are 3, 10. We can do a similar thing with coordinate C, so C is where the line y equals negative 2x plus 16 intersects the line y equals 2. So if we substitute y equals 2, we get 2 equals negative 2x plus 16. If you add 2x to both sides and also take 2 from both sides, you'll get 2x equals 16 take 2, so 2x is 14, and then divide both sides by 2, x will give you 7. So the coordinates of C are 7, 2. If we now look at this triangle, you can see the coordinates at the bottom go from 3, 2 to 7, 2. This tells you the difference in the x coordinates is 4, so the base of the triangle has length 4. If we look at the coordinates A and B now, they go from 3, 2 to 3, 10. The difference in the y coordinates is 10 take away 2, so the height of this triangle is 8. We can now use trigonometry to find the angle x. So if we label the triangle, 8 is the opposite, and 4 is the adjacent, so we need to use tan. So x would equal inverse tan of 8 over 4, which is just 2, and if you type this into your calculator, you need to round to 3 significant figures, and you'll get the answer 63.4 degrees. This question's about the factor theorem. So if we say that this polynomial here is f of x, then this bracket here, 2x minus 5, will be a factor if we do f of 5 over 2, and that gives us 0. So we're going to substitute 5 over 2 into the polynomial. 5 over 2 is just 2.5, so we're going to do 2 lots of 2.5 cubed plus 9 lots of 2.5 squared, take away 11 lots of 2.5, and then take away 60. And this needs to give us 0. Now because this is a show that question, you should show each of these stages to make sure you get the marks. So we're going to do 2 lots of 2.5 cubed, which gets you 31.25, and then 9 lots of 2.5 squared, which is 56.25, negative 11 times 2.5, which is negative 27.5, and then take away 60. If you type all of this into your calculator, you will indeed get 0. Now to fully factorise this, we need to divide the polynomial by the factor 2x minus 5. So we'll write 2x minus 5, and then the polynomial. We first consider what we times our factor by to get 2x cubed. Since we have 2x, the answer would be x squared. We multiply this back through, so x squared times 2x gives you 2x cubed, and x squared times negative 5 gives you negative 5x squared. We can now subtract these. The 2x cubes would cancel, and then we have 9x squared take away negative 5x squared, which gets you 14x squared. Now we need to consider what we times our factor by to get 14x squared. Since we have 2x, we need to times it by 7x. We multiply this back through. 7x times 2x is 14x squared, and 7x times negative 5 gives you negative 35x. You then subtract these. The 14x squareds will cancel, and then we have negative 11x take away negative 35x, which gets you positive 24x. Finally, what do we times our factor by to get 24x? Well, it's 2x, so we need to times it by plus 12. If you multiply this back through, 12x times 2x is 24x, and 12 times negative 5 is negative 60. And if you subtract these, you'll get 0. So we can see that our original factor, 2x minus 5, times this quadratic, x squared plus 7x plus 12, must give us the cubic, 2x cubed plus 9x squared minus 11x minus 60. Now this quadratic here can also factorise, so our answer would be 2x minus 5, and then if we factorise the quadratic, we get x plus 3 and x plus 4. For this question, we need to do the area of the triangle, which is 1/2 times the base, which is 3x minus 5, times the perpendicular height, which is 3x minus 10. And in the question we're told the area is less than 700, so this must be less than 700. Now if we multiply both sides by 2, the half will cancel, so we'll just be left with the 2 brackets on the left, and 700 times 2 is 1400. We can now expand the brackets. 3x times 3x is 9x squared, 3x times negative 5, negative 15x, 3x times negative 10, negative 30x, and negative 5 times negative 10 is positive 50. So this must be less than 1400. So we've got 9x squared on the left. If we simplify the x terms, negative 15x take 30x is negative 45x, and then we got plus 50, but we could subtract 1400 from both sides, and that will give us take away 1350 is less than 0. Now this quadratic looks pretty scary, but you can actually divide all of the terms by 9. So if we divide by 9 on the left hand side, 9x squared divided by 9 is x squared, negative 45x divided by 9 is just negative 5x, and negative 1350 divided by 9 is negative 150. And of course 0 divided by 9 is still 0. We can now factorise this quadratic. The brackets would be x plus 10 and x minus 15. Now this is an inequality, not an equation, so we end up with 2 critical values, and they are x equals negative 10 and x equals positive 15. So if we imagine the graph of this quadratic, we know it would cross at negative 10 and positive 15, so it would look something like this. The inequality says less than 0, so we're interested in this section of the graph which is below the x-axis. That corresponds to x values in between negative 10 and 15. So the solution to this inequality is -10 is less than x is less than 15. Now there's one extra piece of information we need to remember. We can't have a negative length for this triangle. So for example, if x was something like -9, this triangle would have a negative length, so it wouldn't exist. The shortest side of the triangle is the height, 3x minus 10, so we need to make sure this is positive. So 3x minus 10 is greater than 0. If you add 10 to both sides, you get 3x is greater than 10, and then divide by 3, x will be greater than 10 over 3. If we then combine these two inequalities, we get the full solution, which is 10 over 3 is less than x is less than 15. Here we have three simultaneous equations. I'm going to label them 1, 2 and 3. I'm going to start by working with equations 1 and 2 and eliminating a. So I'll keep equation 1 as it is, and then for equation 2 I'm going to multiply it by 3. So a times 3 is 3a, negative 2b times 3, negative 6b, and 2c times 3 is 6c. And then 11 times 3, 33. Now I'll subtract these equations. 3a take 3a is 0, b take negative 6b is 7b, negative 4c take 6c is negative 10c, and 7 take 33 is negative 26. I'll now do a very similar method but using a different pair of equations, this time equations 2 and 3. I'm going to write equation 3 out, but then multiply equation 2 by 2. So a times 2 is 2a, negative 2b times 2, negative 4b, and 2c times 2 is 4c. 11 times 2 is 22. Again, I'll take away the equations. 2a take 2a is 0, 3b take negative 4b is 7b, 10c take 4c is positive 6c, and 4 take 22 is negative 18. I've now got two simultaneous equations with two unknowns, so I can solve these. Fortunately, the b's already match, so we can subtract these equations. 7b take 7b is 0, and then negative 10c take away 6c is negative 16c, and negative 26 take away negative 18 gives you negative 8. If you divide both sides of this by negative 16, you get c is 1/2. Now that I've found c, I can also find b using one of these equations, if I just substitute c for 1/2. So I'm going to use 7b, take away 10c, but I know c is 1/2, equals negative 26. So 7b, 10 lots of 1/2 is 5, so it's take 5, equals negative 26. Add 5 to both sides, and you'll get 7b equals negative 21, and then divide by 7, and you'll get b equals negative 3. So now I found b. Now I need to go back to one of the very first equations we had to find a. I'm going to choose equation 2 here, since the coefficient of a is just 1. So we have a, take away 2b, but I know b is negative 3, plus 2c, but I know c is 1/2, must equal 11. So we have a, negative 2 times negative 3 is positive 6, 2 times 1/2 is just 1, and this must equal 11. So we have a, 6 and 1 makes 7, and that must make 11, and then take 7 from both sides, and you'll get a equals 4. So the full solution is a equals 4, b equals negative 3, and c equals 1/2. In this question, we're making 4-digit numbers. We're also told that the numbers must be multiples of 5, in which case there are two possibilities. The number could end in a 0, or it could end in a 5. We'll treat these as two separate cases. We'll first look at when it ends in a 0. Now we're also told the number must be greater than 3000 and have no repeated digits. So if we look at the case where it ends in a 0, let's consider the first digit. Now if the number's going to be greater than 3000, this digit must be a 3, a 4, or a 5. So there are three possibilities for this number. The second digit could be any number apart from the digits we've already used. We've already used a 0, and we've already used one number for the first digit, a 3, a 4, or a 5, so that leaves us with 4 possibilities left. This next digit could also be any number, apart from it can't be a 0, it can't be the number we used for the first digit, and it can't be a number we used for the second digit, so there are 3 possible numbers left. And of course for the 0 there's only one possibility. If you times all of these together, you'll find there are 36 possible ways. Now let's consider when there's a 5 at the end. The first digit again needs to be a 3, a 4, or a 5, however it can't be a 5 because we've already got that at the end of the number. so it can only be a 3 or a 4, which means there are 2 possibilities. The next number can be any number that we haven't used yet. We've used a 5 at the end, and we've used some number, a 3 or a 4, at the front, so there are 4 numbers left. This next digit can be any number apart from the ones we've already used, so it can't be a 5, it can't be the number we used for the first digit, and it can't be a number we used for the second digit. That leaves you with 3 possibilities left. And of course there's only one possibility for this final number, it has to be a 5. If you times all of these together, you get 24. So there are 36 ways when it ends in a 0, 24 ways when it ends in a 5. If you add these together, you'll get 60 possible numbers. In this question, the first thing to spot is that the angles 3x and 2x are opposite angles in a cyclic quadrilateral. This means they add up to 180 degrees. So 3x add 2x makes 180 degrees, which gives 5x equals 180, and if you divide both sides by 5, you'll get x is 36 degrees. This means we can find this angle 3x here by timesing 36 by 3, so this angle is 108 degrees. Next, we'll look at the ratio BC to CD, which is in the ratio root 2 to 2. Since we know the length of CD is 5 root 3, we need to manipulate this so the right hand side is equal to 5 root 3. To do this, first divide both sides by 2, so you get root 2 over 2, and then 2 divided by 2 is 1, and then multiply both sides by 5 root 3. If you multiply 5 root 3 on the left, you do root 3 times root 2, which is root 6, so it's 5 root 6 over 2, and on the right hand side, 1 times 5 root 3 is just 5 root 3. From this we can see the length of BC is 5 root 6 over 2. We were also told in the question that AB equals BC, so we know the length AB is also equal to 5 root 6 over 2. If we now look at the triangle ABC, we can use the rule that the area is equal to 1/2 AB sine C. So if we do 1/2 times 5 root 6 over 2 times 5 root 6 over 2 again, and then times sine 108. If you type this into your calculator, you'll get 17.8. In this question, we need to find the size of angle EBG, which I'm going to mark on the diagram here. We're going to start by looking at this red triangle BCG. In this triangle, we have the top here is 7 centimeters, and the right hand side here is 24. If we use Pythagoras then, we can find the hypotenuse, so if we do the square root of 7 squared plus 24 squared, you get 25. This means the line BG is 25 centimeters. We're now going to look at the triangle on the bottom of this shape, triangle EGH. For this triangle we have 2 sides, one of them is 7 and the other one is also 7. So if we use Pythagoras again, the square root of 7 squared plus 7 squared gives you square root 98. So the length of line EG is square root 98. Now the lines BE and BG are the same, therefore BE is also 25 centimeters. So what we have now is a triangle where we're trying to find an angle and we know all 3 of the lengths. To do this you use the cosine rule. So cos of the angle will equal b squared plus c squared, which is 25 squared plus 25 squared, minus a squared, which is take away the square root of 98 squared, over 2bc, so it's over 2 times 25 times 25. If you type the right hand side here into your calculator, you'll get 0.9216, and then if you do inverse cos of this, you'll get the answer for the angle A, which if we round, gives us 22.8 degrees. To start this question, we're going to write the 3n plus 2 all squared as 3n plus 2 times 3n plus 2. We'll then expand both of these brackets, so for the first one, 3n times 3n is 9n squared, 3n times 2 is plus 6n, 2 times 3n is also plus 6n, and 2 times 2 is 4. We'll then expand the second bracket, but be careful to write all of these terms in a larger bracket. So it's take away, and then we'll do a bracket, and then put the terms inside this bracket. So n times n is n squared, n times 3 is plus 3n, 1 times n is plus 1n, and 1 times 3 is plus 3. So if we leave the first bracket as it was, the negative here will affect all of the terms in this second bracket. So it's actually take away n squared, take away 3n, take away n, and take away 3. We can now simplify by collecting like terms. So we have 9n squared take n squared, that's 8n squared. We've got 6n plus 6n take 3n take 1n, and that gives you plus 8n. And then 4 take away 3 is plus 1. What we're now going to do is factorise 2 out of the first 2 terms. So we have 2 and then a bracket. 2 times something will give you 8n squared, that's going to be 4n squared, and 2 times something will give you 8n, that's going to be plus 4n. And then there's a plus 1 at the end. Now that we've written it in this form, we can show it's an odd number. Since n was an integer, this whole bracket here must also be an integer. So what we have is 2 times an integer, which of course is even, and then we add 1 to it, and even plus 1 is odd. To work out the gradient of a tangent to a curve, you need to differentiate it. So dy by dx, we do 3 times 1/5, which is 3/5, and then reduce the power from 3 to 2, so it's x squared. And then to differentiate negative x squared, we do 2 times negative 1, which is negative 2, and then the power goes down from squared just to 1, so it's just x. And then when differentiating negative x, you get negative 1. In the question we're told that this tangent is going to be parallel to the line y equals 4x minus 9. The gradient of this line is 4, since it has 4 before the x. So we need to set our gradient function equal to 4. We need to rearrange this in order to solve it. First of all, take 4 from both sides. If you take 4 from the left, the negative 1 will become negative 5, and if you take 4 from the right, you get 0. Now we're going to times both sides by 5 to remove the fraction. If you times 3/5 x squared by 5, you get 3x squared. If you times negative 2x by 5, you get negative 10x, and negative 5 by 5 is negative 25, and 0 by 5 is still 0. This quadratic factorises. It would go to 3x plus 5 and x minus 5, which gives you 2 solutions. X equals negative 5/3, and x equals 5. The first thing to do to solve this equation is rearrange so all of the terms are on the left. So we have 3 cos squared x already. If we add 2 cos x to both sides, it's plus 2 cos x, and then take away 1 from both sides, so take away 1, and this now equals 0. This is actually a quadratic equation in cos. To make this a bit easier to see, we're going to substitute y for cos x. So instead of 3 cos squared x, it's 3y squared, and instead of plus 2 cos x, it's plus 2y, and then minus 1 equals 0. You can factorise this quadratic. It's 3y take 1 and y plus 1. This gives you 2 solutions, so y equals 1/3 and y equals negative 1. But remember, y equals cos x. So instead of y equals, we can write cos x equals. So cos x equals 1/3 and cos x equals negative 1. We just need to solve these, and then we've solved the equation. In order to do this, we're going to draw the graph of cos. We'll start with the first equation, cos x equals 1/3. So there will be a line horizontally at 1/3, and we need to find the 2 points where it intersects the cos graph. You can find one of them using your calculator. If you do inverse cos of 1/3, it will give you 70.5 degrees. So that must be the one on the left here. To get the other one, we can use the symmetry of the graph. We do 360 take away 70.5, and you'll get 289.5. Now we'll focus on the second part of our solution, cos x equals negative 1. So if we draw a horizontal line at negative 1, there's only one solution here, and you should know this one already, it's at 180 degrees. So we have 3 angles, 70.5, 180, and 289.5. Thank you for watching this video. I hope you found it useful. I've included the grade boundaries for the 2021 paper. This will give you an idea of how well you've done. Check out what I think you should watch next and subscribe so you don't miss out on future videos.